Hi everyone, welcome to Multiplying Rational Algebraic Expression. Now, let's have now the structure of multiplying rational algebraic expression. It starts with one rational algebraic expression, which is a over b, multiply to c over d. What happens there is that you multiply all the numerators, so you have a times c, and then b times d. Then when you multiply that, the product would be a c over bd. Okay, let's have now an example here. Multiply 2 over x and 4 over 7, or 4 7. So let me get my pen. So you have now 2 over x times, let me have that as a circle, okay, and then 4 over 7. So based on the structure, you multiply all numerators. So you have now 2 and 4. The answer would be 8. And then x times 7, that would be 7x. So the final answer would be 8 over 7x. Okay, let's have now another example. Multiply 2x over 3 and x minus 1 over 5. So let me just get again math 10. So you have now 2x over 3. So that's a fraction, algebraic fraction, and then multiply by x minus 1 over 5. Now, on the structure, you multiply everything in the numerator and then multiply in the denominator. So you have now 2x. Let me just get in the process x minus 1 because you need to multiply. And then all over 3 times 5. Now, let's multiply it by distribution property. So 2x times x, that will lead you to 2x x squared minus 1 all over, 2x times 1, that would be, let me just have that, let me erase that. Okay, that should be 2x times negative 1, that would be 2x all over 3 times 5, that would be 15. So the product of 2x over 3 and x minus 1 over 5 is 2x squared minus 2x all over 15. Let's have another example. Multiply 4 over x and x squared over 8. So, let me have a pen again. Working on that. So you have now 4 over x times x squared over 8. So, when you analyze now the problem, so when you have that on the structure, so you have now 4, then multiply by x squared. And then you have another in the denominator, you have now x over 8. So, you can simplify this by canceling the common factor. You can see 4 and 8 has a common factor of 4. So, you can cancel that out. So this would be 1 and this would be 2. And then here you can cancel as well. X squared and x. So this would be 1 and this would be x. So multiplying the remaining. So you have now 1 times x, you have now x. And then 1 times 2, that would be 2. So the final answer, multiplying 4 over x and x squared over 8, is x over 2. Okay, let's have now this one. Multiply h over h squared minus 2h plus 1 and cube of h minus 1 over 2h plus 1. Now, in this case, factoring would be a skill that is needed. So let me just get my pen and answer this one. So you have now h over, remember that h squared minus 2h plus 1 is a perfect square trinomial. You check. Square root of h squared is h. Square root of 1 is 1. Multiply h and 1, that would be h. And then multiply to 2, that's 2h. So, verifying the perfect square trinomial. So, therefore, you can have it as h minus 1 or the square root of h minus 1. That's a perfect square trinomial. And then multiply. So, you have now h minus 1, the cube of h minus 1. And then you have now the denominator of 2h plus 1. Now, working on that, you can cancel there because it's a binomial. It makes 1. So, remember, you can cancel this one. It's 2. Then this would be 1. So, you have now, in a sense, you have now h times h minus 1 over, this is 1 already, so you have now 2h plus 1. Others would accept this answer, h times h minus 1 as a factor, or when other books or references, they would agree to answer if you multiply that h times h will be h squared minus h over 2h plus 1. So, in my case, I would like to have this answer. However, in some other references, they might use this answer. Okay? So, this would be fine and others might work on this one.